Starship is ready for its 4th flight. Webb finds the most distant galaxy ever seen. A new way to detect Hawking radiation and fresh volcanoes on Venus. All this and more in this week's Space Bites. Well, are you ready for the 4th attempt of launching SpaceX Starship? We got the news this week that SpaceX is targeting June the 5th at the earliest to take another crack at launching Starship. Once again, they're going to blast off a Starship on top of Super Heavy. It's going to separate. Starship is going to fly to orbit. The Super Heavy is then going to attempt to return and land gently into the water in the Gulf of Mexico, while Starship is going to continue onto orbit and then is going to attempt to deorbit through the atmosphere and make its own soft landing somewhere in the Indian Ocean. And this is sort of chosen because this is a way for them to be able to have a trajectory where they don't have any potential of getting near population areas. That sounds safe, wise. Obviously, there's like a ton of little changes they're going to make, small lessons that were learned from the previous launch attempts. One big change is they're going to eject the hot fire staging segment, sort of in between the top of the Super Heavy and the bottom of Starship, and this is going to be destroyed. And Anton, my producer, really wants us to sort of focus in that this means that Starship is no longer going to be fully 100% reusable if they have to actually dispose of this ring on every launch attempt. We'll see whether they can figure it out and bring that back into the era of reusability. So all eyes are on Starship for June 5th. Obviously, I'm going to be watching the launch, and if whatever happens, I'll try to provide you some coverage after the launch is complete. Speaking of human launches, even sooner than that, we should get a launch of the Boeing Starliner carrying 2 astronauts to the International Space Station. Now, we've been waiting a long time for this launch. There've been a lot of delays, and we're finally there. Now, we're not entirely out of the woods yet. There is an ongoing potential leak of helium on the spacecraft, but it's not urgent enough that NASA thinks it's worth canceling the launch. So they're going to keep an eye on it and still launch. The 2 astronauts, Butch Wilmore and Suni Williams, have arrived in Florida, and they're getting ready to actually board the spacecraft. If all goes well, the rocket will blast off on June 1st. But we've seen so many delays, even just in the last couple of months, that don't be surprised if it gets a few more delays until they're finally ready to blast off. Webb finds the most distant galaxy ever seen. All right, here is a record that I don't think is going to last very long. James Webb Space Telescope has found the most distant galaxy ever seen. Now, the galaxy is called JADES GS Z14-0, or JADES Z14. This is a galaxy that is seen with a redshift number of approximately 14, which roughly correlates to about 290 million years after the Big Bang. And we've heard a lot of announcements about the most distant galaxy ever being seen. In fact, as soon as James Webb launched, we got some announcements of people seeing galaxies that were potentially even less than that, 250 million, 230 million years after the Big Bang. But the big difference is that this galaxy has been very heavily studied. So back in January 2024, Webb stared at this one galaxy for 10 hours. And that's the kind of length of time that you need to be able to do a really accurate spectroscopic analysis of this galaxy. You stare at this one galaxy long enough, you can start to see these chemical abundances. You can see the absorption lines and the emission lines of different chemicals. You can detect their current redshift, and that tells you how fast the galaxy is moving away from us, and so what time in the universe you are seeing it at. Only when you take that time and do that spectroscopic data analysis can you get that accurate number, and Webb just hasn't had the time to analyze all these galaxies. So there's probably other galaxies that it has seen that are farther. It's just that nobody has put in the time to actually confirm. But so far, this is the record breaker, 290 million years after the Big Bang. And what's interesting is this is in a time that astronomers refer to as cosmic dawn. This is when those first galaxies were coming together to form the larger structures, the more mature galaxies like the Milky Way that we see today. This is one of the main science goals of James Webb, was to identify these galaxies and try and figure out that merger process to see how we get these larger structures. A new way to measure the rotation of black holes. We don't know much about the black holes. Really, we can know their mass and their rotation. Maybe we can know their electrical charge. And so there are ways to measure the mass of black holes, and there are a few ways to measure the rotation of black holes. But astronomers are always looking for new ways to figure out how fast is that black hole spinning. And so researchers had a wonderful event happen recently that they're able to use to be able to calculate the rotation speed of a black hole. It's called a tidal disruption event. And this is where a star is consumed, torn apart by a black hole. Some of the material is ejected off into space, and some of the material falls down and joins the accretion disk that is surrounding the black hole. So a couple of years ago, astronomers detected one of these tidal disruption events around a supermassive black hole, and they were able to observe it for hundreds of days, watching as the light was changing over time as the black hole was adding this new star to its accretion disk. And they were able to detect a wobble in the accretion disk as this new material was being added. And from that wobble, they were able to calculate the rotation speed of the black hole. What they found was that the black hole is turning at 25% the speed of light, which sounds like a lot, but in fact, that's relatively slow for black holes. Black holes can spin much faster than that, really approaching the speed of light itself, essentially the maximum speed that is predicted by Einstein. Many black holes reach that maximum speed limit and then they just can't spin any faster than that. So it's exciting that astronomers have a new way to be able to measure the rotation speed of black holes. They just need to watch stars get sacrificed to be able to make that speed calculation. A way to detect Hawking radiation. The late great Stephen Hawking, an astrophysicist, did a lot of work thinking about black holes. And one of his best known predictions is that black holes should evaporate over time, that they should release radiation, other particles called Hawking radiation. And then as the black hole does this, it is decreasing in mass. But the problem is that this happens on an incredibly slow scale, longer than a human lifetime to be able to detect these particles coming from individual black holes. And so we need a place where black holes are evaporating more rapidly. And so the amount of Hawking radiation that's coming off from a black hole is dependent on the mass of the black hole. If you have something that is, say, the mass of a small asteroid, it's going to evaporate very quickly. It's going to be releasing a hot flash of gamma radiation and then it's going to disappear. But we don't have any black holes like that. But maybe there's a way to make them. Astronomers published a new paper where they proposed that if you had merging supermassive black holes, as these black holes are coming together, they might release what they call morsels of smaller black holes, essentially the remnants that are coming out of this merger process. And so there might be a way to get tiny black holes out of the two black holes as they come together. And then these morsels can have all kinds of different masses, and it might be that it's small enough that they can then evaporate and release a blast of gamma radiation. And so the astronomers proposed that if you watch the mergers between various black holes, you might be able to detect the gamma radiation coming from the morsel black holes that are being thrown out and they're evaporating around this merger process. And the cool thing is that we have the kinds of telescopes today that could be able to detect this radiation. Proof that massive stars are disappearing. Over the last decades, astronomers are coming to the conclusion that very massive stars are just disappearing. The traditional idea of what happens at the end of a massive star, like something with more than 8 times the mass of the sun, is that it uses up all the fuel in its core, it then implodes, produces a supernova, and forms a black hole or a neutron star at the heart. But astronomers have found that a lot of the kinds of stars that should be detonating as a supernova are just disappearing. They call them unnovas as opposed to a supernova. But the problem is they're really hard to find. I mean, you've got a star and then you do a survey a decade later and you notice that that star is missing. Now, it could be that there's just dust in the way, or that there was dust in the beginning, or there was some mistake in the observations. So there's lots of reasons to explain why a star might have disappeared. But in a recent study, astronomers looked at a binary star system that has a star with about 25 times the mass of the sun and a black hole with 10 times the mass of the sun. And the two stars are orbiting a common center of gravity. But what they found is that the orbit is too perfect, too circular. In other words, that you could have a star with that kind of mass and a black hole with that kind of mass. So obviously the black hole was the result of a star that went supernova. You could get that if the star didn't die violently, if it just was a star and then it was a black hole and just collapsed in on itself and just kept going in the exact same orbit that it was going before. It wouldn't be the exact same orbit because it would have lost some mass, but I guess if it didn't explode as a supernova. Okay, I'm going to go with that. All right. And so this very perfect star system gives an evidence that you can get giant stars collapsing into black holes without that pesky supernova in between. So hopefully we will find more and more examples of this, and it gives us another way that stars can die. Every week we do a vote on our channel where you tell us what you thought was the best space news of the week, the most intriguing space news of the week. And the winner this week was that Voyager 1 is back online. So thank you everybody who took the time to vote in last week's poll. Now we will post the new poll onto our community tab on our YouTube channel. But if you're just scrolling on YouTube, you should see the votes. Go ahead, take a second, give us a vote, tell us what you thought. The best chance to be able to see this vote is to subscribe to the channel and then watch a bunch of our videos to tell the algorithm that you want more of our sweet space news. Chang'e 6 is about to land on the moon. In addition to Starliner blasting off on June 1st, we should get a landing on the moon on June 1st. And that is the Chinese Space Agency's Chang'e 6 mission, which is going to be landing at the south pole of the moon in the Apollo crater in the South Pole Aitken Basin. If Chang'e 6 lands safely, its job is to scoop up 2 kilograms of lunar regolith. It's then going to package that up and put it into an ascent module that's going to fly up into lunar orbit. It's going to meet with an orbital spacecraft, which will then bring that capsule back down to Earth so that scientists can analyze this. And this is scientifically fascinating. I mean, you're seeing samples that are coming from the south pole of the moon near to the permanently shadowed craters at the moon. And so we can learn about how much water ice is mixed in with the regolith in those southern regions. Scientifically, the far side of the moon, the south pole of the moon, I mean, these are regions that geologists would love to get their hands on to be able to analyze these samples. But also, think about like what this is. I mean, you've got a spacecraft that is launching to the moon. It is separating. Part of it is going into orbit around the moon. It is then sending a lander down to the surface of the moon. It is collecting samples. It's sending an ascent module back up to space, and that is returning safely to Earth. That sounds like the Apollo missions, right? These are all the pieces of the technology that you would master in order to be able to send humans to the moon. And of course, this is China's goal. This is them demonstrating that they have the various technology pieces figured out to be able to send astronauts eventually to the surface of the moon. Of course, it will be hundreds of kilograms of astronauts and not 2 kilograms of lunar samples. But, you know, this is how it starts. Vulcan isn't a planet after all. It looks like Spock is homeless again. Back in 2018, astronomers found evidence that there is a super-Earth exoplanet in the system 40 Eridani. And according to science fiction lore, to Star Trek lore, this is the homeworld for Spock. And so plenty of news outlets, possibly even us, reported that Spock's homeworld had been found. Of course, it couldn't last. And so researchers did a bunch of double checking and some very intensive observations using the radial velocity method to observe the star. They found that the evidence of an exoplanet passing in front of 40 Eridani was perfectly explained by a large group of sunspots on the surface of the star, which matches its 42-day rotation period. In other words, what looked like a planet was actually a bunch of sunspots on the surface of the star. And as it was turning, those sunspots were coming back into view every 42 days. So Spock's homeworld has disappeared again. Didn't that happen in the movie? Wasn't Vulcan destroyed? Was it Romulus that was destroyed? Yeah, Vulcan was also destroyed. Yeah. It's canon, yeah, so this is how it happened. There are active volcanoes on Venus. Now, it's long believed that the surface of Venus isn't volcanically active. We got NASA's Magellan mission that went to Venus. It used radar to scan the surface of Venus, and it didn't find any active volcanoes. But not so fast. Researchers have been looking through the data returned by the Magellan spacecraft very carefully. And fortunately, it took a bunch of images over the course of several years, from 1990 to 1992. And it imaged many places on the surface of Venus multiple times. And so if there was some kind of volcanic eruption, then they would be able to see the changes. And upon careful inspection, and by comparing the data sets over those multiple years, scientists have actually found evidence of active volcanism on the surface of Venus. So there's two regions where they found that vents were releasing lava out onto the surface of Venus, and it was creating lava flows between 3 and 20 meters deep across dozens of hectares on the surface of Venus. And so actually it turns out Venus is a lot more active than we thought. I'm going to talk some more about Venus at the end of this episode, so stay tuned for that. And speaking of Venus, we've learned that the Japanese Space Agency has lost contact with their Akatsuki mission. This was the only operational mission that we had at Venus right now. It was a $300 million mission that the Japanese Space Agency sent to explore and understand the cloud tops of Venus. And unfortunately, it failed to be able to make its original orbital insertion. But then the folks at JAXA were able to use a bunch of gravitational slingshots, and 5 years later, it was able to limp finally into the orbit of Venus and perform a lot of observations and send home what I think are some of the most beautiful images of the cloud tops of Venus. And unfortunately this week, JAXA told us that they have lost contact with the spacecraft. They're going to attempt to restore contact, but don't be surprised if this is the last we hear of it. But like I said, I'm going to talk some more about this at the end of this episode. Now, I try to wrap up these episodes with a really cool picture or video, and today I'm able to give you both. So first, let's take a look at a really cool image that comes from James Webb. This is of the dwarf galaxy NGC 4449, and this is an example of a starburst galaxy. In other words, it's a galaxy that is undergoing an intense amount of star formation. You can see that at the center, you've got all of the stars, and then surrounding that, just these giant clouds of gas and dust, which are the fuel for this galaxy. And you don't normally get a starburst galaxy without some kind of event happening. So it's believed that this galaxy either merged with another one or came too close and had some kind of tidal interaction with another galaxy, and that kicked off this era of star formation. And then a video of flying over the Nila Fosse region on Mars. And this was made based on orbital imagery from ESA's Mars Express mission, which has been there forever and has taken a lot of really high resolution images of the surface of Mars. And then they were able to turn that into this sort of virtual flyover above Mars. The region is called Nila Fosse, and it comprises parallel trenches that are hundreds of meters deep across the surface beside a massive impact crater. And in fact, these trenches are known as graben, where you've got the ground in between two faults, fractures up and breaks apart, and you get these sort of slumping and trenches and really interesting terrain. And so it just shows you that Mars has a lot of really fascinating places that we really need to explore. Now, you're watching this video, but right now I'm writing my weekly email newsletter. I do it every Friday and I send it out sort of at the end of the day. And, we're reporting on half dozen to 10 interesting stories here in Space Bites, but we cover many, many more, dozens and dozens of stories on Universe Today, and I write them up for the newsletter. So if you want to get just a great overview of everything we're covering on Universe Today, definitely sign up for my weekly email newsletter. Just to give you some examples of what we're covering. Do you remember the announcement of Dyson spheres? Well, there's a more boring explanation for what might cause them. Starlinks can be surprisingly bright if you're a pilot. And how much water would a self-sustaining moon base require? So to find out the answers to all that, you're gonna have to subscribe to the newsletter. The newsletter goes out to more than 70,000 of my closest friends. It's completely free. I write every word. You can unsubscribe if you don't like it for whatever reason. So go ahead, go to universetoday.com/newsletter to sign up. Now, like I said, I want to talk about Venus some more, but first I want to thank our patrons. Thanks to Abe Kingston, Andrew Gross, David Giltonen, Dennis Alberti, Dustin Cable, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Modzo, Paul Robach, Stephen Krasaki, Stephen Filer Munley, and Vlad Shiplin, who support us at the Master of the Universe level, and all of our other supporters on Patreon. When I think about the work that's being done on Venus, the stuff that we're reporting on this week about potential active volcanism, I think about the fleet of spacecraft that are on their way to Venus over the next decade. We've got 2 missions coming from NASA. We've got Da Vinci Plus and Veritas. And so, for example, when you had that ground radar scan that came from the Magellan mission, we're going to have a much higher resolution version of that from one of those missions. And when you think about that scanning of the surface of Venus from the Magellan mission, we're going to get a much higher resolution version of that. And so we're also going to be able to compare the original surface features back in 1990, 1992 to the surface today. And so hopefully with artificial intelligence, with various techniques, they should be able to spot all of the weird new stuff that's appeared on the surface of Venus. We're going to get a much better understanding of the atmosphere of Venus. We're going to search for the conditions of life in the atmosphere of Venus. So many missions, 2 missions from NASA, 1 mission from the European Space Agency. The Indians are sending a mission, and there's going to be a private mission going to Venus in probably first compared to all of the other missions. And so Venus is going to go from this world that has just been chronically, tragically underexplored to a place that's going to feel as vibrant and scientifically exciting as what we've seen on Mars. So stay tuned, get ready for just an avalanche of cool new space science that's going to be coming from Venus over the next decade or so. All right, we'll see you next week.